This is just a video on why you should never, ever, 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 ever use any non-dimmable compact fluorescent lamp or LED lamp or whatever on dimmers. This is one that was pulled from somewhere where some idiot had put in a dimmer, or put in a compact, or put in a piece of crap Lights of America LED lamp on this dimmer. It's a combination dimmer fan speed control. And what happened is that literally burnt the device. Hard to see on video because this camera is not very good with macro shots, but some of the thermal paste on the triac, and the bit where it's actually touching the epoxy covering the actual semiconductor die in the device, is turning brown. And it turned brown, and big smoke stain right where the triac was, so not good. But then again, it was used with a non-dimmable load. And the reason that that is not a good idea is because compact fluorescent lamps have really crappy current draw, as will be explained in a little bit. With resistive loads like incandescent lamps, the current is a nice sinusoid matching the potential, and in this case on this graph the potential is green, current is blue. That's just a cat. With this, the current is in phase with the load, and there's no nasty harmonics, no nasty... That's the cat in question, by the way. Cats are weird. Anyways, and this is the case with nice resistive loads. With compact fluorescent lamps, you get that. And these can be in the hundreds of milliamperes in normal operation, which isn't too bad, but real nightmare as far as power quality is concerned. With dimmers, they can get into the multi-ampere range, which is very bad. The reason for this really yick nasty current draw is because of the way the front end of virtually all compact fluorescent lamps use. What they do is it's a fairly typical AC to DC conversion circuit, and it's just a Graetz bridge and a ripple suppression capacitor. The reason for the really nasty current drop is that because whenever the instantaneous potential on the ripple suppression capacitor is greater than the main supply, there's no current, pretty much, and it's the lulls in the waveform, and whenever the and then when the instantaneous supply potential goes above the instantaneous capacitor potential, you get a really nasty current spike. And this is already fairly bad but manageable-ish kind of with compact fluorescent lamps without getting dimmers in the mix. When you do that, you can get much higher current pulses, because a dimmer, like virtually all dimmers nowadays, use what's known as a triac, which is the burnt thing in the little dead dimmer I just showed you. The way, and one aspect of them is that there needs to be a certain potential across the device before it will actually fire and conduct. And for the little bits on this graph, those little shaded in areas are the bits where the triac is not conducting. And the reason, and what happens is that because of that extended bit where the device is not conducting, it means that the potential across the ripple suppression capacitor in the lamp gets a lot lower than normal, so consequently you have a much greater potential difference. And so, and consequently, when the capacitor, or when the triac fires, because also these are designed for a resistive load, not the more complex load like a electronic ballast. you get a really nasty current spike, which is bad for the triac, as you saw, because the thing literally burnt, and it's bad for the lamp because it means that you've got very high ripple currents in the capacitor, which is this little tiny piece of crap Chinese electrolytic, which are just bad on their own. And it's bad for the diodes because, again, you've got multi-ampere pulses, like you can get 4 amperes to 8 amperes or more, which is not good. And the diodes that the Grates bridge in the lamp uses are pretty much going to be 1N4007 rectifiers, maybe 1N4004s, but usually 1N4007s, which are probably not honestly rated because ordinarily proper 1N4000 series diodes are 1 ampere maximum rated current, and you're dealing with peak currents many times in excess of that, so it means that you're going to kill the diodes. And also because they're Chinese, you can't trust their ratings. And it's also bad because most compact fluorescent lamps, are pretty much all of them that do employ some form of overcurrent protection, use what's known as a fusible resistor. A fusible resistor is not a fuse. A proper electrical fuse, depending on how it works, or depending on the specific type, is designed to interrupt some degree of excess current. You can have things like delay fuses for things like motors and lamp loads, where you can have totally benign surge currents that only last for a couple of cycles at most, and then everything's okay. They don't trip instantly until you get pretty much a dead short. Or you can have ultra-fast acting semiconductor fuses, which are designed to blow pretty much instantaneously upon any kind of excess current, because they're designed to protect things that really, really, really don't like that. Fuse resistors don't do that at all. What a fuse resistor is designed to do is it is designed to limit peak currents for purposes of device protection. They are not designed to act as fuses. Oftentimes, you can find fluorescent lamps on occasion that do use proper fuses, but they're these little tiny 100 mil diameter, maybe 3/8 of an inch long, if that, tiny little things that totally unacceptable breaking spec for and clearance spec for mains use, but then again, made in China, that's the norm. What happens is that the resistor turns into a heater, because that's pretty much what electric heaters are. But this is often an issue because it's often on the outside of the printed circuit board, right next to the ballast casing, and oftentimes if you've seen a failed fluorescent lamp where there's some little red glowing component burning a hole in the ballast casing, that's that fuse resistor. And because, again, power dissipated in a resistance is equal to the square of the current times the potential, you can double the current in a resistor and get 4 times the power dissipated at it. And you can get a lot more than 4 times and you can get a lot more than double the fault current with these. You can get like order of magnitude greater than normal. And they really don't like that, and it causes all manner of problems. But this is why you should never, ever, 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 under no circumstances at all, use one of those on a dimmer. Ever. Don't do it. You can get dimmable compact fluorescent lamps, but generally they're pretty much, the results you get are a lot worse than what you get if you just use incandescent lamps, which don't have any of these problems. But then again, the greens are just, I don't think any profanity in any mortal tongue exists to describe just how bad these things can be. Yes.